In this video, we're going to continue the series on basic concepts of organic chemistry. We're doing an exam style questions video on the naming and representing of formulae of organic compounds, and this follows part 1 and part 2, and it's your chance to try the question. So remember, this is a stop the video style, do the question and then listen to the explanation and go through it to prepare yourself for all those questions you're going to face in the exams. So our first one is a multiple choice question, and it's based upon this molecule here, which is an ester. And you can see this ester group here, which you may have come across in your GCSEs or other qualifications. Now, this ester has 10 carbons in it, and you can see the 10 carbons here. And then it has different numbers, and we have to find out which different number of hydrogens it has, because obviously the oxygens are all the same as well. And we can see there's 2 oxygens there. So what they typically do is try and get you to find out the hydrogens, because the hydrogens aren't shown on skeletal formula. Now, these are all molecular formulas, just showing the amount of each type of element and not showing you the structure or anything like that. Okay, so let's get going. So let's put that to the side. And here we have our molecule. So first of all, we need to look at this and go, right, how many bonds to each carbon? So the most important thing is that we're looking for each time is 4 bonds. Okay, we're looking at 4 bonds, and that's to each carbon. Right, now, with 4 bonds to each carbon, we can start to look at the molecule and go, right, okay, how many bonds do we have to this carbon? So every time you change direction, there's a carbon. Okay, and there are carbons at the end of terminal ends like this, or ends like this. You see this dot here, that's a carbon as well. So then we look at it and we go, right, let's start from the benzene that we've got here, and we can see there's 1, 2, 3. So there's 3 bonds to this carbon, and therefore I need 4 bonds to each carbon, and so there is a hydrogen coming off to do that extra bond. So let's try and do that there. And if that is the case, you can follow this around really quickly. Remember, this is only a 1-minute question in the exam, so it should only take you about a minute each multiple choice, and that varies slightly depending on the complexity. But you can look, that's the same as this, it's the same as this one, same as this one. So I can very quickly just go, right, okay, there we go. There's another hydrogen, and then we go to this one. There's another hydrogen, and then from this one, there's another hydrogen again, and this is exactly the same again. So there's another hydrogen. So we've done those hydrogens on the benzene. Now let's have a look at the hydrogens on the chain and this end of the benzene here. So we look at the end of the benzene, we can see 1, 2, 3, 4. So these are 4 bonds to that carbon. So I can't add any other bonds, so I can't add any hydrogens. So we look at this one, there are 2 bonds, 1 there, 1 there. I need 4 bonds, so that means there are 2 hydrogens coming off there. So there we go, there's 1, okay, and there is your second one there. Okay, so we've got 2 hydrogens there. This is exactly the same group as the one before. So again, we put our hydrogen there, and then our hydrogen there. Okay, so we've got our hydrogens building. Now, we then go to the next part, and we go here. 1, 2, 3, 4. There's already 4 bonds, don't need any more. And then we look at the oxygen here and say, right, do we put any hydrogens on the, would there be any hydrogens on the oxygen, or do we see hydrogens on the oxygen? Well, actually, we only see hydrogens on oxygen when we've got things like alcohols and things like that. But let's just check anyway. So here's 1, 2 bonds, and that's an oxygen. And if it's an oxygen, it's 2 bonds to each oxygen. So we can see there's 2 bonds to this oxygen, 2 bonds to this one. And then that leaves the last one. So the last one here, we can see there's 1 bond going to this carbon, which means we have 3 hydrogens coming off. Okay? So 3 hydrogens coming off. So if I was you, this is how I do it in the exam. I'd quickly go across each one, and then we can do a very quick count. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if that is that, that means our answer is going to be A. Okay. C10, H12, O2. We're going to move on to our second example of this type of question, where we've got a slightly simpler molecule, which is a cycloalkene. So it's an alkene, and it's a cyclo compound. So on here, we've got some molecular formulas again, and we want to do exactly the same thing as we did before. But I'm going to show you a little trick to do this a little bit quicker. So we're looking at this again, and we're going to put our different ones on. So quickly, we're looking for 4 bonds again, so we can look 1 bond there, and there you go. There's your hydrogens on there because you have 4 total bonds to that carbon. There is 1, 2, 3, 4. So 4 bonds to this carbon, so I don't have to put any on. There's 1, 2, 3 bonds to that carbon. So if there's 3 bonds to that carbon, okay, I'm going to do that. And put one more, remember 4 bonds to each carbon. And then look at these carbons, they're all exactly the same. Okay, they all have 2 bonds coming to them. If that's the case, they need 4, so therefore they need 2 extra bonds. So we're going to quickly put our lines in here for each one. And there you go. And then as we go along, there we go. And the last one. All right, and then we can quickly go and go, look, there's our hydrogens. They're in. And we've got all of our hydrogens. It's taken us, I don't know, about 2 minutes or something like that to get that all done. And then we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we think the answer, therefore, is, because all the carbons are the same, we didn't have to count them, okay, we know that is C7H12. Now, if that's the case, let's look at the quicker way of doing it, arguably. And you can do this with different types of functional groups and different general formulas. But one tip I would give you is remember your general formulas. It can really, really help you. So first of all, we've got an alkane and an alkene. An alkane and an alkene, CnH2n plus 2, and then CnH2n. So the difference between these two is 2 hydrogens. We then have a cycloalkane, which has the same molecular formula or general formula as the alkene. So what you think now, if a cycloalkane is CnH2n, what is a cycloalkene? Now you can use this difference here. So this is an alkane, this is an alkane, this is an alkene, and the cycloalkene is an alkene. So what's the difference between here and here? Well, it's 2 hydrogens. So the difference between the cycloalkane and the cycloalkene is going to be 2 hydrogens. Notice I put the -2. So what I can do is I can just do it a little bit quicker. And I can say, right, quickly count the carbons. Well, it's a hexagon, so it's 6, 7. So we've got C7. We then take the 7 times by 2, which is 14. And then we -2, which is 12. So without actually doing all of this, which took a little bit of time, if you've got a simple one like this, I know this only works if you've got, for example, only one simple double bond like that. If you have multiple, I'm afraid you're just going to have to count. And then we can get to this answer here, which is, okay, C7H12, and we can do that really, really, really quickly versus doing the slightly slower method. We're now going to look at a style of question that introduces a new functional group that you're not familiar with and isn't necessarily on your course, because they can do this in the exams as long as they give you a structure, as long as they give you some information about that, that means you can deduce what the answer is. They can do that. So here we have ethers. Now ethers are a homologous series, and hopefully you remember that definition, which is compounds that have the same functional group but differ by a successive CH2, so basically they get longer. And it says the functional group is ROR. So if we look at these, we can see, right, here is the O, and here is an R group. So at the moment we're introducing R groups as alkyl groups, but R groups can essentially be any group as long as you tell the person what the R group is. So you have to be R equals, show what the group is, okay, and then you can just label this as R. But in this case, ROR says that you have a group one side and a group the other side. And we've got exactly the same one as you've got here. So an R there and an R there. It then shows you the names of a simple one and the names of a name of a more complex one. So if we look here, we see methoxy. So the oxy must tell us that it's an ether. And we can look here and we can say, right, okay, methoxy, well, that's meth. That's 1 carbon. And that's that is 2 carbons. Now, normally when you come to name these things, you have a stem, a parent chain, which is the longest chain. So we can see in these 2 examples that ethane, in this example, is longer than meth, so it ends in A and E. And we can see that the longest chain here is 1, 2, 3, 4, which is bute. Okay, and so that comes at the end as the parent chain as well. So we can see both of them, ethane and butane, parent chain, okay, longest chain on that oxygen. We can then see on the ethoxy, on the 2-methyl, we can see that 2-methyl is on that butane, and it must be counting 1, 2. It can't be counting from that end, because that would be 3. It's counting 1, 2. So if we're going to put a methyl onto one of the chains, we have to count from the oxygen. So it gives us some rules. So I'll just go over those again. The stem is going to be the longest chain. It's going to end in A and E. And then your prefix, which has to end in oxy, will be the shortest chain. And then if you're doing a methyl, the methyl counting comes from the oxygen. You can work this out from the question, but it's good to know anyway. So let's put this across and let's actually do the question. So draw the skeletal formula of the ether ethoxy 3-methyl-butane. So first of all, it's an ether. So I might start with, there's my O. And then I know there's a stem of butane. So, and it says skeletal formula, so I'm going to go 1, 2, 3, 4. So I've done 1, 2, 3, 4. And then it says 3 methyl, so that methyl is on the butane. And remember from there, I worked out that I must count from the oxygen. So the oxygen is there, so that is 1. So that is 1, that is 2, and that is 3. So it says 3 methyl, so methyl is just a line like that. So we've got our 3 methyl there. Let's get rid of that dot. Okay, now we've done the methyl and we've done the butane, but we haven't done the ethoxy. So the ethoxy is 2 carbons long because of eth. So 1, 2. So we have here a drawing of an ether, which you didn't know how to draw ethers, but you worked it out from the actual question itself. And this is ethoxy 3-methyl butane. We're now going to look at the question where you can draw skeletal structures of 2 different types of hydrocarbons, so one branched and one cyclic. It says they're both saturated, so if they are both saturated, just look down here, so it says they're both saturated, you want the branched, you want the cyclic, and it just wants 1 of each, and it gives you 4 carbon atoms. Now this can go up to 5, 6, 7, 8. Now what I'd recommend you do is when you're looking at this question, do this question again and just change the number of carbon atoms. So practice. Now we want to name each hydrocarbon as well, so it's making it use 2 different skills. So let's go down. So we've highlighted our main areas and we want to name each hydrocarbon. So let's have a look at what we can get. So we've got 4 carbon atoms, and it wants it in skeletal formula. So the simplest one of an alkane, because an alkane is a saturated, so we're looking for alkanes, okay, is if you just do this. Now this is 1, 2, 3, 4, and this is butane. So this is not one of my answers. Okay, so that's not one of my answers, but I just thought I'd do it as a starting point. So that's 1, 2, 3, 4. Now what you can do with skeletal formula is you can just move the carbons around. And as long as you move the carbons around, it will have the same overall molecular formula. Just move the things around. So if our 4 carbons would be like that, but we want it to be branched and we want it to be cyclic, let's move around these to make it so it's branched. So for example, a branch means that it's coming off one of these, and you can't put it on that end. So if you put it on that end, it turns it back into butane. Put it on that end, it turns it back into butane. So the only place you can put it is right in the center. Okay, so right in the center. So here we go. So here we have methyl. So it's got a methyl. It's on position number 2. So there's your 3 carbons on position number 2. So this would be methyl. And it would be methyl probe because it's 3 carbons. And it's saturated, so it's an alkane. And if we were doing it really well, we would have to put that methyl there. So that's at position number 2. So we've got 2-methyl propane, and that is our branched. And we can't really do anything else because we looked at taking this off and putting it this end, that end, but we also can't make it any longer, any shorter than 3. If we make it any shorter than 3, it's eth. Let me just show you like this. And if we start putting branches on that, well, it just turns it back into propane. If we start putting a branch on that, turns it back into that. So you can't go back down to eth. And I'd recommend that you draw a few of those as well. But for now, let's not worry about that. So there's our answer. We've done our branched, so let's take that off. Okay, we're then going to go to our cyclic. So to do our cyclic, we take our original 4 carbons and we just make them into a ring. So the only way you can make 4 into a kind of ring is to make it into a square. So with that square, you can say 1, 2, 3, 4. So it's bute again. It's a cyclo. It's an alkane. It's saturated. There's only single bonds. So this would be cyclobutane. So we've got cyclobutane. Now, that's good. That will get you your marks. We've named, and we've done cyclic, and we've done a branched. But let's look as if there's one more. So can you think of one more? Okay, so if we then take this, and instead of making a ring of 4, we make a ring of 3. So we've made a ring of 3. Now we have a total of 4 carbons, so therefore we can put a methyl on there. So if that's the case, what is that? Now what's the name of that? 3 in a ring, so it's cyclopropane. So cyclopropane. Now, should have given myself a little bit of space, but that methyl is on it as well. So this is methyl cyclopropane. So either that one be correct or that one. Apologies, this methyl should be before the cyclo, it's just we haven't got any space here. So methyl cyclopropane or cyclobutane or 2-methyl propane. This all comes from this butane with the 4 carbons branched and 2 cyclic. So our last question is going to be on naming alkanes, and we just simply put name the compound because essentially what's going to happen is they'll do a little intro on it, explain where the molecule might come from, and then they'll say just name the compound, and that's the question. So here we've got our compound, but you don't have to just do this compound. If you really want to get good at this, just draw out compounds and then practice naming them. You can make them up. You can just elongate the chain, add a few branches, all this kind of thing, and just check then with your teacher whether your naming is correct. Now, also, at the end of this video, you will find there is an exam style questions worksheet, and there's many examples for you to practice naming there as well. But let's get on with naming this hydrocarbon. Let's move to the side. So we've got it. And we're going to look at, first of all, it's the stem. So we're looking at the longest chain, and we've gone over that in the previous video. So the stem here is going to be 1, 2, 3, 4, 5. Now can we think of anywhere longer? So 1, 2, 3, 4. 1, 2, 3, 4, 5. So 5 is definitely the longest. So if we're going to name this, it's going to be pent. So now it's going to be pent. We can also see it's got single bonds only between carbons and carbon and hydrogens. Therefore, it is an alkane. So this is pentane. So then we look at it and say where we're going to start from. So we can start from here or we can start from here because they both were 5. It doesn't really matter. So let's just start here on this one. So this would be 1 and then go to 2. Okay, and then that one is 3. And then 4, and then 5. So then we can look at this and go, that's a methyl, it's 1 carbon, that's at number 2. So that's 2-methyl, and then we've got another methyl coming off, and that's at number 3. So we've got 2 methyls, so that's dimethyl, so let's call that dimethyl. Okay, and then let's look at 2 and 3. And we have to say where each methyl is, so it's 2, 3, dimethyl pentane. And that's a classic type of question. They don't make it much more complicated than that, but I would suggest you do much more complicated just to get yourself really, really, really comfortable with naming.